let's start out by writing the product rule. So the product rule says that if you have two functions u of x and v of x, to take the derivatives of their product with respect to x, all you have to do is take the first function and multiply with the derivative of the second function, and then add the opposite, add the product of the second function times the derivative of the first. Should be all too common by now. Now, if we multiply both sides by dx, this is legal by the way, we then simply have the instantaneous change of u of x, v of x, or the differential du of x, v of x, equal to u of x times the instantaneous change in v of x, plus v of x times the differential du of x. Lastly, integrating both sides, we then have the product u of x times v of x equal to the integral of u of x times dv of x, plus the integral of v of x times du of x. Subtracting the integral of v of x times du of x over and simplifying the notation of u of x and v of x to just u and v respectively, we then have our following integration by parts rule that you see in all textbooks. Now at first glance, you might wonder, how does this rule tell us to find the integral of a product of two functions, since you might not see the integral of a product anywhere? I mean, we have the integral of u dv and v du, but how are u dv and v du product of two functions? Well, this is where what I believe most books fail in explaining integration by parts, and where some clarification is needed. Now, our original two functions in our product rule were essentially u and v, correct? Well, if we took the derivative of u and v, we got du dx and dv dx respectively, right? Knowing that u and v were shorthand for u of x and v of x, then du dx and dv dx are simply shorthand for u prime of x and v prime of x respectively. Following along? Multiplying dx over, we then have du equal to u prime of x dx and dv equal to v prime of x dx. And plugging this back in, the books should actually say that the integration by parts is the following. And now we can clearly see that this is the rule for the integral of a product of two functions, where the first function is u of x and the second function is v prime x. And all we have to do to solve this integral is differentiate u of x, finding u prime of x, and integrate v prime of x, finding v of x. Plug them into their respective places, and lastly, evaluate the integral v of x times u prime of x dx. In other words, this rule is best executed when we have a product, given it can't be integrated by simpler methods such as u sub, where the first function, the u of x, can be differentiated, and the second function, v prime of x, can be integrated. Examples where this could work would be such as integrating the product of x and cosine x, where x has a first derivative 1 and cosine x has an integral sine x. And plugging in, we would get the following. So yeah, there's a brief intro to integration by parts, where it comes from, and how and when to use it. I really hope this sheds some light on your understanding of it. And for this video's continuation into repeated integration by parts, stay tuned for my video on tabular method. Until next time, thanks for watching.